young math padawans. It's Mrs. Angel with your lesson for today on factoring trinomials with a leading coefficient. So that means that we're looking at expressions that have three terms, and there is a number out in front that is greater than 1. So there's two methods that we're going to be going over in today's video. We have supergrouping and slip and slide. We're going to get some practice with both of these methods, and then after this, you can pretty much choose whichever one you like going forward. So grab your notes and let's get started. So we're going to start off with a method called supergrouping. So supergrouping works very similarly to factor by grouping and P's and Q's. So over here, we're looking at a trinomial that has three terms, but what I notice about this trinomial is that it now has a leading coefficient. So if you do have a leading coefficient, you can't use your typical P's and Q's factoring method. And because it's a trinomial, we can't use our grouping method. Additionally, I notice that there is no GCF among 2, 15, and 25, so at this point, we're pretty much stuck. That's where the method called supergrouping comes in. So with supergrouping, we're first going to start by playing the P's and Q's game, but this time with a twist. So let's start with the sum. Just like P's and Q's method, the sum is always the middle term. So we're finding two numbers that add up to 15. However, the product is different. In regular P's and Q's, we'd be finding two numbers that have a product of 25. In supergrouping, we're going to grab the first coefficient and the last term and multiply them together. 2 times 25 is 50, and that will be our P's and Q's product. So we're taking the first and last, multiplying, and that's our product. So now we play the P's and Q's game. So what two numbers have a product of 50 and a sum of 15? 10 and 5. Now, here's where supergrouping gets pretty cool. We're going to take 10 and 5, and we're going to break up that middle term 15n into two terms. So we're taking 15n, and we're breaking it up into 10n plus 5n, which I think we all agree is still equivalent to 15n. And then we're just going to bring down our other terms. We have our plus 25 and our 2n squared. Now, what have we just done here? Well, what we've done is we've now created a 4-term polynomial. So notice how we originally had a trinomial with 3 terms. Now we have 4 terms. And I think we can all agree that 10n plus 5n is still 15n, meaning these expressions are still equivalent. Now, how do we factor 4-term polynomials? That's right, we do grouping. So now we're just going to go through our steps of factor by grouping. Step 1, put in your 2 groups. So I'm going to group the first 2 terms together, and since it's addition, the second 2 terms together. Step 2, find your GCFs. The greatest common factor of the first 2 terms, it appears to be 2n, and the greatest common factor of the second 2 terms appears to be 5. So let's go ahead and factor those out. If I factor 2n out of a 2n squared plus 10, I'm left with an n plus 5. And if I factor 5 out of a 5n plus 25, I'm also left with a n plus 5. Do you see a binomial in common? I sure do. I see an n plus 5 and an n plus 5. So that means that our work is correct so far. Let's go ahead and put this into our factored form. So our first binomial will be our 2 GCFs, our 2n plus 5, and our second binomial is our common, n plus 5. And we're done because we've taken something that was a trinomial and we broke it up into a product of 2 binomials, which is what factoring is all about. Let's go ahead and multiply to check. Voila, and we ended with what we started with. So we know that this is the correct factored form of the trinomial 2n squared plus 15n plus 25. That method is called supergrouping. Now, if that was a little confusing for you, don't worry. There's a second method called slip and slide that we're going to go over now. Okay, so we have the exact same trinomial 2n squared plus 15n plus 25. We're going to factor it this time using slip and slide. So the first step in slip and slide is in its name. We're going to slip. Now what that means is we're going to grab the leading coefficient and we're going to slip it down to the last term, meaning we're actually going to just multiply 2 by 25. 2 times 25 is, you guessed it, 50. I like to put my trinomial in quotations because we're no longer working with an equivalent trinomial. We're working in this like alternate universe trinomial. So my trinomial has now become n squared plus 15n plus, and because I flipped that 2 down to the 25, the last term is now 50. Now, these are not equivalent expressions. This is something that I'm just going to use for my P's and Q's. So now that I've written a trinomial with a leading coefficient of 1, I can just play my normal P's and Q's game. So what two numbers have a sum of the middle term 15 and a product of the last term 50? Well, we already did that math right here with supergrouping. Those two numbers are 10 and 5. 10 plus 5 is 15. 10 times 5 is 50. Now, with this method over here in slip and slide, we're just going to factor this norm using our normal P's and Q's. So again, we're still kind of working in this alternate universe here because we changed our original trinomial. Let me set up my two binomials. N times n is how I got n squared, and n plus 10, n plus 5, let's just double check that. 10 times 5 is 50, and 10 plus 5 is 15. Now, hopefully you're thinking to yourself, wait a second, we already factored this using supergrouping, and that is not the correct answer. You would be correct in that, because slip and slide is a two-part method. First, we did our slip. Now we do our slide. So the slide basically undoes the multiplication that we started with. So to do our slide, we're going to grab that same leading coefficient 2, and we're going to slide it underneath both of our constants. We're going to divide 5 by 2 and 10 by 2. Now, in our final step, we're going to simplify these quotients because, again, we started with multiplication, so to undo that, we have to divide. So in our first binomial, 10 divided by 2 is 5. That can be simplified. Great. But 5 divided by 2 is a fraction that can't be simplified as an integer. So when that happens, you're essentially going to grab that 2 and slide it in front of n. What we're really doing here is we're multiplying both of these terms by 2 to cancel out that denominator. So my second binomial here is 2n plus 5. Now let's go ahead and check our work. And it looks like it checks out. Now you might notice that the binomials are in a different order than when we factored this using supergrouping. But by commutative property of multiplication, you can multiply in any order. So 2n plus 5 times n plus 5 is equivalent to n plus 5 times 2n plus 5. These are equivalent products, and they're both the factored form of the trinomial that we started with. Let's go ahead and practice both of these methods on some trinomials. So just to review, these are methods that we use when we're given a trinomial that has a leading coefficient greater than 1. So let's take a look at number 1 here. It looks like here we have a trinomial with 3 terms, and our leading coefficient is 7. I also noticed that it doesn't have any greatest common factors, so we have to use one of these two methods. It looks here that we're being asked to use supergrouping here, so let's go ahead and set that up. I'm going to start by writing out the trinomials in the middle so I have a little bit of space to do my supergrouping. All right, step 1, we are going to play the P's and Q's game here. We're still trying to find two numbers that have a sum of negative 11. So what plus what is a sum of negative 11? The middle term is always the sum. But if you remember what's different with supergrouping, to find the product, we grab the first term and the last term, and we multiply them. 7 times 4 is 28. So we're finding two numbers that have a product of 28. What are our values of P and Q here? All right, so now that we found our P's and Q's, we're going to break that middle term into two terms. So negative 11 is going to be broken up into negative 7x minus 4x. Now we're going to bring down our last term and our first term. So we have now broken this up into a 4-term polynomial. And how do we factor 4-term polynomials? By grouping. If you would like to try to factor this one by grouping, go ahead and do so now. So first step is that we're going to put this into groups. Second step, let's find our GCS. Now let's factor that out. Do we have a common binomial here? Yes, we do, in our x minus 1. So that means we can now fully factor the expression. Our first binomial will be the 2GCS, 7x minus 4. And our second binomial is what they have in common, x minus 1. Now, before we can put the box around our answer, let's go ahead and multiply to check using either double distribute or the box method. It does appear that our check works out, so we know that 7x minus 4 times x minus 1 is the correct factored form of the trinomial that we started with. Okay, problem 2. We again have a trinomial, 3 terms. It does have a leading coefficient greater than 1, and there is no GCS that we can factor out, which means we have to use either supergrouping or slip and slide. Looks like here they want us to use slip and slide, so that's what we're going to do. I'm going to start by writing out my trinomial again with a little bit of space. And the first step in slip and slide is to slip. We're going to grab the leading coefficient and slip it on down to the last term, multiplying 5 and negative 6. We have now changed the value of this expression, so I like to put it in quotations to note that this is no longer an equivalent expression. We're just going to use it to continue our factoring. So our alternate universe expression here would be m squared plus 29m, and then after flipping that down, this now becomes a minus 30. From here, we can play our P's and Q's game. What two numbers have a sum of 29 and a product of negative 30? What P's and Q's are there here? Now, because this is just a normal trinomial, I can go ahead and set up my two binomials. M times m is how we get m squared, and the two numbers that have a product of negative 30 and a sum of 29 are positive 30 and negative 1. Now remember, this is not the correct factored form because we flipped the 5 to the end. Now we have to undo that by sliding it underneath. To undo multiplication, we have to divide, and now we're going to simplify our two binomials. In our first binomial, 30 divided by 5 is 6, so we have m plus 6. But in our second binomial, we can't divide 1 by 5, so we're just going to flip that 5 as a coefficient in front of m, and we have 5m minus 1. And that could be our factored form. Let's check just to be sure. And voila, it appears to be correct. So that means that m plus 6 times 5n minus 1 is the equivalent factored form of the trinomial that we started with. Okay, number 3, we have another trinomial here, 5n squared plus 2n minus 3, with a leading coefficient that's greater than 1, which means we have to use either supergrouping or slip and slide. But it looks like this time you get to choose. So go ahead and do this one now using the method of your choice. Great work, young math padawans. So as you can see with number 3, it doesn't matter if you use supergrouping or slip and slide, you end up with equivalent factored forms. In supergrouping, I ended up with n plus 1 times 5n minus 3, and in slip and slide, 5n minus 3 times n plus 1, which are equivalent. That's it for today's lesson. I will see you next time.